Okay, so this is 5152. This is chapter 5, day 1. We're going to start with vocabulary. So over here, draw a nice big radical. You can put a 7 inside of it, and you can put a big 3 in front of it. Okay, so most people know that the radical itself refers to the sign. So the actual radical symbol itself. You might not remember, though, that a radical symbol is a grouping symbol, which means you have to go inside the radical when you're following order of operations, just like you'd go inside parentheses. So you do that first. Probably you have not heard the term radicand. Another term for radicand is the principal. I don't use principal. The radicand is the stuff that is under the radical. So in this case, it's the number 7. That's your radicand. The root or the index of the radical is the small number. Now, if there isn't a little number in this little V section, the default number is a 2. So you have what's called an implied 2 if there's nothing there. And the index or the root tells you the number of factors needed to simplify. So if it's a square root, which is a 2, that means you need 2 factors. And so for every 2 factors, 1 comes out. If it's a cube root, which is a 3, it's every 3 factors 1 comes out. And as we get going, we end up with 4th roots and 5th roots and 6th roots. And it just tells you how many factors you need to simplify out. So a square root is the 2. And then a cube root would be if you had an index of 3 in that little space. And that would mean for every 3 objects, 1 comes out. For what we're going to do most of the time, they're going to be square and cube, but we do throw in some 4th and 5th roots. And then when you get to pre-calculus, they do 5th, 6th, and 7th roots and some other crazy stuff. Okay, Roman numeral 2. Finding roots, that's what your worksheet will sometimes say. Other times it will just say to simplify. Okay, so number 1, how to do just straight up numbers. Straight up numbers, not letters. So we're going to do square root of 50. So your first step when you do anything really is you factor. In this case, you prime factor, which we've been doing while we were factoring. So, break it down. 50 is 5 times 10. 5 is prime, and then 10 is 2 times 5. So that's prime factored. Move that up a little bit. Okay, and then the rule is, because this is a square root, for every 2 factors, 1 comes out. So because we have 2 5s on the inside, 1 5 goes to the front, and then all that you have left is a 2. Now, this is a fairly simple example, so that actually would be the answer, 5 square root 2. But the unwritten steps are, after you've simplified the factors out, you multiply the radicand, so whatever's left gets multiplied back together, and the scalars, whatever is out in the front, also gets multiplied together. All right, we're going to do another numerical example. We're going to do a negative radical 32. Now, just like a negative in front of parentheses, a negative is just a -1. And if it's sitting outside of a radical symbol, it's being multiplied. We don't write the dot just like we don't write a dot always between numbers and parentheses. We just know a number against a parenthesis is multiplied. Okay, so we're going to prime factor the inside. So 32 is 8 times 4. And 8 is 222. That's something you might want to just memorize. 8 is 222, and then times 4, so 2 more 2's. So that's the first step, is prime factoring. And now, since this is a square root with an implied 2, for every 2 factors, 1 comes out. So 2 2's, 1 comes out to the front, 2 more 2's, 1 comes out to the front, and I only have a single 2 left. So that's your step 2. For every 2 factors, 1 comes out. Now, step 3 is multiply the radicand, multiply the scalars. So 2 times 2 times -1 is -4. I'm not going to put the multiplication dot, it's implied. And there isn't anything to multiply left because it's just a 2. So -4 radical 2. Now, in terms of types of answers, anytime you have a number that's trapped under a radical, that is an irrational number. So this is an irrational answer because it has the radical in it. And irrationals are non-repeating and non-terminating decimals. And anytime you put a simplified radical into a calculator like square root 2, it's going to give you a very long decimal, 1.4121. And then it basically just chops off everything else. But the number actually goes on forever. In your little solar calculators, it usually goes out 12 digits in its memory bank, and it dumps everything else. On a graphing calculator, it goes out 39 digits, and then it dumps everything else, which means the minute you input a square root into your calculator, your number is no longer perfect. It has error. And anytime you use that decimal, the error grows and grows and grows. So we don't put things in a calculator until the very end. So you use a calculator only at the end. When you've done all the simplifying and all the math, then you do the calculator if you're supposed to go to a decimal. Most of your homework is going to be exact answers or rational or exact answers. Oh yeah, this is also exact. I need to make sure I tell you that. This is your exact form, which means perfect. Any math you do with the square root 2 will be perfect, no error. This answer with the decimal is rounded, which means it has automatically error in it. The minute you round, you have error. In pre-calc, if you round in the first step of the problem, by the end of the problem, you'll actually have the wrong answer, even if you did the right math. Used to drive my pre-calc kids nuts. Okay, so let's do another practice problem. 3 square root 12. So to simplify this, we're going to prime factor the 12. So 12 is 4 times 3. So 2 times 2 for the 4, and then a 3. There is no index listed, so the default is 2. So for every 2 factors, 1 comes out. I have 2 2's, 1 comes to the front. It gets multiplied by any other scalars that are out there, and I end up with 6 radical 3. And that is, of course, the exact answer. All right, so example 4, we're still in numerical radicands. Let's try a cube root. So 2 cube root of a 24. So your basic first step is the same. You're going to prime factor. So 24 is what? 8 times 3. So 2 2 2 for the 8 times 3. Now this one's different because it's got a cube root. So the cube root means that for every 3 factors, 1 comes out. So I have 3 2's, 1 comes out to the front, it gets multiplied by the scalar, and we get 4 cube root of 3. All right, let's do a fraction. Square root of 81 over 100. One of your radical properties is you can combine radicands or separate radicands if they're fractional. So you can leave it like that, or, which you'll more often do, separate into square root 81 over square root 100. And the reason the separation is useful is because now you can evaluate them separately. 81 is 9 times 9. 100 is 10 times 10. So 2 9s, 1 comes out. 2 10s, 1 comes out. And again, this is a property of radicals. It's a reciprocal property, so you can do it either way. Combo to separate, separate to combo. Those are all legal. You do whichever one gets you simplified the fastest. All right, what about decimals? Let's say we've got 0.0036. There's a couple ways to do this without a calculator. The first way, this is the way I do it, is I count the number of decimal places. 1, 2, 3, 4. So there are 4 decimal places. And then I know that if I want 2 factors that match, they have to match perfectly. So I divide that by 2, and I get 2 decimal places per number. Now, I know that 36 is 6 times 6. So what I'm going to do is write a factor with 6, but that has 2 decimal places. So 0.06 times 0.06. And each of those has 2 decimal places. So 2 places for that one, 2 places for that one. So 2.06's, 1 comes out. So that's how you do decimals. Okay, so those are numeric examples, numbers only. Now we're going to do with variables, but we're going to break it in half because the rules are different. So the first one, so for number 2, we're going to do variables with an even index, which we have to handle differently than variables with an odd index. Okay, so to do variables with an even index, you have to understand one dilemma. Here's the dilemma. If x squared equals 4, what was x originally? Was x positive 2? Was x negative 2? And you look at that and you say, well, which one is it? Well, the problem is when you square a negative times a negative is a positive, and a positive times a positive is also positive. So if this is all you have to look at, you don't know which one it was. It could have been 2, it could have been negative 2. We don't know. So for the which one, the answer is we don't know. So we do both. And sometimes one of them might be extraneous. Sometimes both are extraneous. Sometimes neither is extraneous. For simple stuff, most of the time, there's no extraneous. So how do we deal with this? So when you take a square root of both sides, 2 x's, 1 comes out, we go, okay, my x might have been positive, my x might have been negative. Now, for 4, there's no mystery. 4 is 2 times 2. Square root of 4 is 2. The mystery is on the x, not on the number. And that's a misunderstanding that comes up about in Algebra 1 due to the style of problems they give you. Your brain starts to think that this is a plus minus 2, and it isn't. It's just 2. This is the one where we're like, what was x? We don't know. So you end up splitting the expression into a positive x and a negative x, and you solve them separately, which in an easy problem like this one is not that hard. You get x equals 2, and then on this one, if you multiply or divide both sides by a -1, you get x equals -2. So you have two different answers. You can write your answers like that. So for format, you can write your answers in roster notation, 2 and -2. You can write your answers as a ±2. That's another way to do it. Okay, so this is only a dilemma if you have an even index. You get x equals ±2. There's a third one, which is the absolute value of x equals 2. All three of these mean the same thing. Most of the time, we're going to do the ±2 and the absolute value. And in the beginning, when it's easy, use both of them. Write your answer two ways, because when it gets more challenging, you'll find that one of the two ways will work and the other one won't, depending on the problem you're doing. So those are your answer formats. All right, so let's do an example of a variable problem with an even index. So example 1, we'll start easy. Square root of 2x squared. So you start by prime factoring, so that's 2xx. 2 x's, 1 comes out. It is plus and minus. So your answer is either the absolute value of x radical 2 or plus and minus x radical 2. And again, I want you practicing both, because as we get to the more challenging ones, the plus minus stops working. Okay, let's do another example. Again, we're going a little harder. Negative square root of x plus 5 squared. Okay, so I have, when I prime factor this, I have x plus 5 times x plus 5, 2x plus 5s, 1 comes out. There is a -1 or a negative scalar already out there. And this is an example of where you have to use the absolute value or you have to do a bunch of algebra. If it's absolute value, it's negative absolute value x plus 5, and you're done. Now, if you have to give answers as two separate answers, you're going to hate this, but it's how you do it. So you have to split it. You do have that negative out there in the front. I'm going to call that a -1 times, and then you'll have positive x plus 5. And then on the other one, you'll have your scalar of -1, and you'll have a negative x plus 5. So one x is positive, one of them's negative. Use your parentheses. So on this one, negative times a positive is a negative. So it's negative times x plus 5, and distribute the negative. Negative x minus 5. On this one, a negative times a negative is a positive, and when you distribute the positive, x plus 5 doesn't change. And those would be your two answers. So you have to figure out if they want you to split it and actually find the two answers, or if you're okay doing the absolute value bars and stopping there. Kind of depends on the circumstance. Okay, example 3. Square root of 2x squared plus 20x plus 50. Now, in order to simplify a radical, it has to be factored. So this is regular ABC factoring. So out of a 2, a 20, and a 50, I can take a 2 out. That leaves me with x squared plus 10x plus 25. The 2 stays put, and then this trinomial factors into x plus 5 times x plus 5. So you do have to get it into factored form. If it's not factored, you can't simplify it, and that trinomial just stays there. It doesn't change. So if it doesn't factor, you're done. That's it. It's good. But this does factor. So 2x plus 5's, 1 comes out to the front. I'm going to use absolute value bars, and then I'm left with square root 2, and that would be my answer. You can see how absolute value bars can be really handy. A lot less work. Okay, example 4. We're going to do the square root of x to the 4th. We're back to square root. So when you factor x to the 4th, it's x, 4 x's. So using the rule, for every 2 x's, 1 comes out. So 2 x's, 1 comes out with absolute value bars. 2 x's, another 1 comes out with absolute value bars. So what we have now is nothing left in the middle, but I do have absolute value of x squared because I had 2 of them multiplied together. Okay, so let me ask you, if x is positive, if x is a positive number, what's the sign on x squared? We don't know? Okay, let's write it out. So if x is positive, I have a positive x squared, and a positive times a positive is a positive, so positive x squared. If x is negative, I have a negative x squared, and a negative times a negative is a positive. So in both cases, whether it's positive or negative, when you square it, it ends up positive. So in this problem, your answer is x squared. It's not plus or minus, it's not absolute value. So if you pull an even number of x's out, the signs disappear because they square out. All right, last one of these, and then we're going to go to the odd index ones. So this is example 5. We're going to do the square root of negative 36x quantity squared. Okay, so we're going to prime factor this, but if it's a square, before you hit the primes, just write it out. I have negative 36x times negative 36x. So get rid of the square. And then now you can prime factor. A negative times a negative is a positive, so the negatives go away. So I have a 36 times a 36, and I have an x times an x. And the negatives multiplied out. So 2 36's, 1 comes out. It's not plus or minus because it's not an x. I have 2 x's, 1 comes out. That one is plus or minus. So I'm going to put it in absolute value bars. There's nothing left. So your answer is 36 absolute value of x or plus minus 36x. So that's how you handle squares and cubes under a radical. Write them out with multiplication and then break each piece down. Okay, so last category, category 3. This is, we're going to work with variables with an odd index. So all those were variables with an even index. So odd index would be cube root, 5th root, 7th root, and so on. So the biggest difference between an odd index and an even index is in an odd index, there's no mystery. There is only one answer. Because the even index caused perfect squares and the sign squared out. With an odd index, what you see is what you get. If it's a cubed number and it's negative, the number's negative. If it's a cubed number and the number's positive, the number's positive. So again, you can see why this is true. You have x cubed is x times x times x, which is x cubed, and it's positive. If I cube a negative x times a negative x times a negative, well, a negative times a negative is a positive times a negative is a negative, and the negative comes out of the parentheses and moves to the front as a scalar. All right, so let's do an example. We'll start easy. We're going to do the cube root of negative 27x to the fourth. You can't have a negative under a radical with an even index or it's imaginary, but this is an odd index, so it's okay. So how do we do this? There's a couple ways to do this. I find this one is the one that most people prefer. If your number is negative and it's a perfect cube, and you know this is 3 times 3 times 3. So if it's negative, tag the negative on all 3 3s. Negative 3, negative 3, negative 3, and then do your 4 x's. So this is a cube root. So for every 3 factors, 1 comes out. So for 3 negative 3s, 1 comes out to the front. And then I can take out 3 of my x's, but not 4 of them. So 1, 2, 3, 1 comes out. So what I've got is negative 3x cube root x. So if the number underneath is negative and you know that it's going to come out, just split the negative amongst your 3 factors. That usually works the best. When does it not work? Here's where it doesn't work. If you have a negative under a cube root, that negative is the same thing as a negative 1. So that's like negative 1 times 5. The negative 1 simplifies out. And the reason it simplifies out is if I go negative 1 times negative 1 times negative 1, I get a negative 1. So I can factor a negative 1 into 3 identical negative 1 factors. 3 of those, 1 comes out to the front. So this is going to simplify into a negative cube root of 5. So in other words, if it's an odd index, the negative always comes out. Because you can always take a negative 1 and break it into 3 pieces, 5 pieces, or 7 pieces. Okay, we're going to cover adding and subtracting, but we're going to do the easy one today, which is multiplying. And the main thing about multiplying is figure out if you're allowed to multiply and then actually do it. So number 1, the roots have to match. If the roots don't match, you can't multiply as a radical. Okay, so let's say the roots do match. Then you multiply the radicands, so just combine them under one radical. And then you multiply the scalars. And then anything else that needs to be simplified, like more things that are going to come out, then you simplify. Again, we're going to do adding, subtracting, and dividing, but this is the easy one, so we're going to start with the easy one today. Let's say you've got 3 square root 5x times 2 square root 10x. All right, so your first question is, do the roots match? Well, this is an implied 2, and that's an implied 2. So they are both root 2, so yes. The roots match. That means we're allowed to multiply. If, by the way, they don't match, you're done. That's it. You can put the scalars together, the 3 and the 2, but you can't do anything with the radicals. Okay, So now we're going to multiply the radicands. So I'm going to put the 5x and the 10x under the same radical. So I have 5x times 10x. And then we're going to multiply the scalars. So the 3 and the 2 out front. So 3 times 2. So multiply the radicands, multiply the scalars. So 3 times 2 is 6. And inside here, these are not prime factored. So this is where you're going to simplify by prime factoring. So I have a 5 times x. 10 is 2 times 5 and another x. So once it's prime factored, which is the simplify part, 2 5s, 1 comes out, it gets multiplied by the 6. 2 x's, 1 comes out, its absolute value, and I have a 2 left inside. So my answer is 30 absolute value x radical 2, or plus and minus 30x radical 2. So that's how you multiply. Multiply the radicands, multiply the scalars, simplify the new radicand. Any questions about multiplying? All right, that is the end of the notes. Any questions about any other parts?